So today I'm going to walk you guys through some particle motion problems. You will need a calculator in order to solve some of these, so make sure that you have a calculator handy. So a particle moves along the x-axis such that its position for t is greater than 0 is given by the function p of t. Use this information to complete exercises 1 through 4. So number 1, what are the values of p prime of 2 and p double prime of 2? Explain what each value represents. So if we find p prime, just take the derivative. So the derivative of e to the t is e to the t minus 5. So if we find p prime of 2, that would be e to the second minus 5, which is 2.389, rounding to 3 decimals. If we find the second derivative here, the derivative of e to the t is e to the t. The derivative of 5 is 0. So if we plug in 2 into p double prime, it is e to the second, which is 7.389. So what did we just find? Explain what each value represents. The first derivative is velocity at t equals 2. The second derivative is acceleration at t equals 2. Looking at number 2, based on the values found in part A, what can be concluded about the speed of the particle at t equals 2? Give a reason for your answer. So if you remember, the speed, is it speeding up or slowing down? If it's speeding up, velocity and acceleration have to have the same sign. If it's slowing down, they have to have different signs. So since p prime of 2 is positive and p double prime of 2 is positive, the particle is speeding up. So we can say the particle is speeding up at t equals 2 because velocity at 2 is positive and acceleration at 2 is positive. Or you can say that they have the same sign. Number 3, on what intervals of t is the particle moving to the left and to the right? Justify your answer. Again, if you think about our 5 commandments, the particle is moving to the left whenever velocity is negative and to the right whenever it's positive. So it all goes back to velocity. So if we look at the velocity function, which is e of t minus 5, we need to look where it's 0. So again, you can use your calculator for this, and you will find that velocity is 0 when t equals 1.6094379. Okay, I'm not gonna take any or do any rounding. So if I draw a line representing the sign of my velocity function, and I want to look at the sign to the left. So on your graph, if you look to the left of that 0, the velocity is below the x-axis, which means that it's negative. If you look to the right, it is positive. So we can say that the particle is moving to the left from negative infinity to 1.609 because v of t is less than 0 at this point. We can say that it's moving to the right from 1.609 to positive infinity because v of t is positive. Number 4, does the particle ever change directions? Justify your answer. So if you remember, in order for a particle to change directions, the velocity has to be 0, but acceleration is not. Which means that our graph of our derivative looks like this. At this point, the velocity is 0, but that function still has a slope, okay, which means that the acceleration is not 0. So does the particle ever change directions? Yes, at t equals 1.609, because v of t changes from negative to positive, and acceleration is not 0. So let's look at number 5. The graph of v of t, the velocity of a moving particle, is given below. What conclusions can be made about the movement of the particle along the x-axis and the acceleration of the particle for t is greater than 0? Give a reason for your answer. So if we're looking at the velocity or the movement along the x-axis, we want to know, is it moving left or right? This is the graph of velocity. So if velocity is negative, the particle is moving to the left. So we can say that the particle moves left from 0 to 2. So there's an asymptote at 0. Okay, and this is because velocity is less than 0. It's negative. On the other hand, we can say that the particle moves to the right from 2 to infinity. And that is because velocity is greater than 0. It's positive. Now, whenever we're talking about acceleration, we need to look at the slope of this graph here. So the slope starts out really, really steep, but it's gradually getting more shallow. So we can say that the acceleration is positive because the slope is positive, but decreasing. So let's look at number 6. If the position of a particle is defined by the function x of t for t is greater than 0, is the speed of the particle increasing or decreasing when t equals 2.5? Justify your answer. So again, thinking about speed, velocity, and acceleration need to have the same sign in order for it to increase. If speed is decreasing, they have different signs. So first, let's look at our velocity function. So if we take the derivative, we get 3t squared minus 18t plus 24. If we plug in 2.5, you would get negative 2.25. If we look at acceleration, so take the derivative of our velocity function here, you get 6t minus 18. And if you plug in 2.5 into the acceleration, you would get negative 3. So since velocity and acceleration have the same sign, but it's negative, the speed is increasing. And don't forget to put the time interval, so at t equals 2.5. So the position of a particle is given by the function p of t for t is greater than 0. Answer questions 7 through 9. So what is the average velocity from t equals 1 to t equals 3? So average velocity, that's our slope formula, right? So velocity average is the position at 3 minus the position at 1 over 3 minus 1. So whenever you plug in 3 into the position function, you get negative 62. And then if you plug in 1, you get negative 16 all over 2. So this equals negative 23. This is your average velocity. So number 8 says find the equation for the velocity of the particle. So that means we have to take the derivative. So v of t is going to equal 3t squared minus 18t. Okay, so that's our velocity equation. Number 9 says for t is greater than 0, find the acceleration when the particle changes direction. So we need to find when the particle changes direction, and then whatever that t value is, that's what we plug in to our acceleration function. So first things first, acceleration is going to be 6t minus 18. So the particle changes direction. That's whenever velocity equals 0. So if we do some factoring here, so the particle or velocity equals 0 when t equals 0, and when 3t minus 18 equals 0. So you get that t equals 6. So if you were to look at the graph of your velocity, you have zeros at 0 and 6. Okay, so if we're talking about a particle changing direction, this piece of information right here is very important. For t is greater than 0. So we cannot take into account t equals 0. So we are only looking where t equals 6. So if we plug in 6 into our acceleration, we get that a of 6 is equal to 18. So that is the acceleration when the particle changes direction.